Hi everyone! In this video, you are going to learn about sets, an introduction. So what do you mean by a set? A set is a collection or group of well-defined objects or things that follow a certain common rule. For example, a set of female presidents in the Philippines, a set of consonants in the word algebra, and a set of counting numbers less than 2. There are examples of non-sets. So a set of books. A set of books is not a set because it is not specific. A set of students. It is also not a set because the students are not specific. What do you mean by students? Students from where? Another is a set of good athletes, a set of difficult subjects, a set of tall students in a class, because it has something to do with your own perception. Next is the naming of a set. The capital letters of the English alphabet are usually used to denote a set, like A, B, C until Z, or set A, set B, set Z, or set C until set Z. The letters used as elements of sets are usually written in lower cases. Each member or object is called an element of that set which it belongs to. And it is represented by this symbol and is read as belongs to, or is an element of, or is the member of. For example, set X, which is the element of 2, 3, 4. So by symbol, we say 2 is an element of X, 3 is an element of X, and 4 is an element of X. Another example, we have Y is a set of string instruments. Thus, the elements of set Y are guitar, violin, ukulele, and harp. So in symbol, we say guitar is an element of Y, violin is an element of Y, ukulele is an element of Y, and harp is an element of Y. So let's proceed with the cardinality of a set. It is denoted by the symbol n of x, which means the number of elements in a set. So the cardinality of a set is the number of elements in a set. For example, set A, which is the element of n, O, R, M, A, and L. So the cardinality of set A is 6 because there are 6 elements. N, O, R, M, A, L. We also have methods in writing a set. First is the roster method. In this method, each element of the set is listed and enclosed in a pair of braces. For example, W is a set of counting numbers between 1 and 5. So by roster method, we say, or we write W, which has the element of 2, 3, 4. Another example, I have set X is a set of string instruments. So by roster method, we write X has the element of guitar, violin, ukulele, harp. Y is the set of planets in our solar system. By roster method, Y has the set of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Z is a set of vowel letters. So by roster method, we write it as Z has the element of A, E, I, O, U. by rule method, in this method, the rules for membership are indicated. So instead of listing the elements of a set, the rules for membership are indicated. So it can be written in the form X, which has the line, and then X, which can be read as set of all X such that X is A or an, then succeeded by the rule for membership. For example, I have a set W which has 2, 3, and 4. So by rule method, we write it as W is a set of all X such that X is a counting number between 1 and 5. Another example, X, which is the element of guitar, violin, ukulele, and harp. So by rule method, X is a set of all X such that X is a string instrument. Another example, Y, which is the element of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So by rule method, Y is the set of all X such that X is a planet of our solar system. And Z, which has the element of A, E, I, O, U, by rule method, we write it as Z is a set of all X such that X is a vowel letter. Now we also have types of sets. The first type of set is the finite set. A set is said to be finite if in counting the elements of a set, the counting comes to an end. For example, set A has the element of 5, 9, 10, and 13. So if we count the elements, we will end to 4. So there are 4 elements, 5, 9, 10, and 13. Set B, which is a set of days in a week. So there are how many days in a week? We have 7 days in a week. For set C, which is the set of whole numbers between 0 and 10. So what are the whole numbers between 0 and 10? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Another type of set is the infinite set. A set is said to be infinite if in counting the elements of a set, the counting never comes to an end. For example, I have set D, which is the set of stars in the sky. Can you count the stars in the sky? No. Another example, set E, which is the set of whole numbers. So we don't know where it should end if we count all the whole numbers. Another example is set F is a set of all X such that X is a counting number. So that is only the same with the set of whole numbers. Another type of set is the empty set. A set without an element is called an empty set or null set, and it is denoted by the symbols, these symbols. For example, the set of all people in your math class who are 10 feet tall. Is there anyone in your math class who is 10 feet tall? No, right? Another example is the set of all digits that are greater than 10. So there is no digit greater than 10 because the digits are only 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another type of set is the universal set. It is the set that consists of all the elements being considered in a particular problem. So the universal set is represented by letter U. For example, the set of all digits is a subset of the universal set of digits. So the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the set of all digits is the subset of the set of all digits, so meaning it is the subset of itself. So the set of whole numbers is a subset of the universal set of all whole numbers. So take note that the empty set or null set denoted by this symbol is the set which contains no elements. So the universal set U is a set which has the property that all sets under consideration are subsets of it. Subsets. The set X is a subset of the set Y, written as X is a subset of Y if every element of X is an element of Y. If Y has at least one element that is not in X, then X is called a proper subset of Y, denoted by X is a proper subset of Y. So consider the sets A and B given below. We have set A, which is the element of 1, 2, 3, 4, and 5. And B has the element of 2, 4, and 5. So, B is a subset of set A, or by symbol, we say B is a subset of A. Also, B is a proper subset of A, or B is a proper subset of A by symbol. So, B is the subset of A, and at the same time, B is the proper subset of A, because there are elements in A that is not in B, but all the elements in B are in A. And also, any set is a subset of itself, but not a proper subset. And the empty set is a subset of any non-empty set. So, empty set is a subset of any non-empty set. Take note of that. So, consider the sets A, which is the element of 1, 2, 3, 4, and 5. Then, if I have set B, which is the element of 1, 3, 4, and C, which is the element of 3, so set B and C are proper subsets of set A, while D, which is the element of 2, 3, 6, and E, which is the element of 1, 2, 3, 4, and 5, are not subset of A. So how do we solve the number of subsets? So to solve this number of subsets, we use the formula n is equal to 2 to the power of hashtag E. So where hashtag E is the number of elements in a given set. For example, list down all the subsets of the following. K, which is the element of A, B, and C. So the subsets are A, B, C, the null set, A, B, C, AB, AC, and BC. So if we count, we have 8 subsets. So by using the formula, n equals 2 to the power of hashtag E, this will become n is equal to 2 to the power of 3. And 2 to the power of 3 means we need to multiply 2 by itself 3 times. So 2 times 2 times 2 is 8. So another example, I have M, which is an element of 1, 2, 3, and 4. So the subsets are 1, 2, 3, 4. This is itself. The set M is the subset of itself. We also have the null set, the one element subset, 1, 2, 3, and 4. The two element subset, which is 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. And the three element subset, which is 1, 2, 3, 2, 3, 4, 1, 3, 4, and 1, 2, 4. So if we count, we have 16 subsets. So by using the formula, n equals 2 to the power of hashtag E, n is equal to 2 to the power of 4. And 2 to the power of 4 means 2 times 2 times 2 times 2 times 2. So n is equal to 16. Let's proceed with the equality of sets. Two sets, x and y, are equal. Written x is equal to y. If x is a subset of y and y is a subset of x, that is, the two sets have exactly the same elements. If x is a subset of y and x is not equal to y, we write x is a proper subset of y and say that x is a proper subset of y. For example, we have set of 1, 5, 7 and 5, 1, 7. So these two sets are equal sets because it doesn't matter the order of the elements. Another, we have a set which contains 1, 5, 5, and 5, and another set which has 1 and 5 only. So these two sets are equal sets because if there is a repeating elements, we can also write that one as one element. So if we have H which contains 7, 8, and 11, and J is 7 and 11. So sets H and J are not equal because there is an element in H that is not in J. Equivalent sets. Two sets are said to be equivalent if they contain the same number of elements. Here, the number of elements of both sets are the same, but elements may differ, and it is denoted by this symbol. For example, A has the element of x, y, z, and B has the element of a, b, c. So, there are three elements of A, denoted by the cardinality of A, which is 3. And there are three elements of B, or the cardinality of B is 3. Hence, A is equivalent to B. Another example, we have C, which has the element of 1, 2, 3, 4, 5, and D has elements A, E, I, O, U. So the cardinality of set C is 5, meaning it has 5 elements. And the cardinality of set D is also 5, meaning it also has 5 elements. So, by symbol, we say C is equivalent to D. Next is disjoint sets. Two sets are disjoint if they have no common elements. For example, set X, which has 3, 6, 9, 12, 15 as its elements, and set Y, which has 1, 5, 7, 11, and 13 as its elements. So these two sets are disjoint sets because there is no common to the both sets, even at least one element that is common to them. There is none. So sets X and Y are disjoint sets because they have no common elements.